Clearly what I'm going to talk to you about is the capstone experience, the capstone part of the degree. And right after me, Fiona Doyle, our executive dean, will be presenting. She'll talk more about the overall structure of the course, structure of the degree. So I only want to talk about really this one component within it, which is the capstone. And of course, I think you can understand that this is a really important part of what you do during the year. You'll have a great experience with your courses, both the technical courses and the leadership and broader types of materials. But when you go to those interviews, I think people will expect that what you learned in your courses, that you've retained it, that they won't have those kinds of questions. I think they will ask you, tell me about the project. What did you do on the project? It's your chance to tell a story about something that you did, that you were interested in. What did you do that was different? So there's a lot of opportunity to pick something that's both of your interest and something that that you can really tell a nice story about and kind of build a career almost from, it doesn't have to be directly, but to use that for what you're going to do next. And so let me kind of start with, what are the basics here? The basics are that there's just a few components of a capstone project. First of all, there will be a faculty advisor. Somebody from Berkeley will sign off on the master's report, the thesis that you basically write by the end of the year. It starts also with a project statement, some sort of problem, and I'll explain where these problems come from in a minute, but there's a starting point. What is this problem that you're going to take on? There's generally an outside partner that's involved, so a company or sometimes it's a government organization or other organization. Now, there's really kind of two categories here. One category is where the environment that you're doing this capstone project in is made out of the laboratory of one of the professors on the department. And the problem is, and the industry partner, is more a relationship with that laboratory. So you might do something in sustainable energy or in bioengineering or something like that, and there's a laboratory that that really is doing a lot of other work in a related area. So that professor is really creating this problem, and it's inspired by the relationships that they already have with some companies that are in that area. There's another type of problem, and that type of problem is where the company, it's more outside in. The company has just created this problem, or somebody at a company has created this problem, and we present the problem almost directly to you, and the company is providing that infrastructure. They might provide you the equipment, they certainly provide the problem, they provide more of the advising. And this type of project, we tend to call it a virtual internship. So you can almost think of it like an internship. You're doing all the work here, but you're getting most of your advising and the resources from the company. So both of these exist in parallel. And then, of course, the fourth part is you. There's typically 3 to 5 students that are on any one of these projects. Okay, so I think that's good. I think you've been looking at sample posters for a while. I just thought I would throw some up on the slides, give you just something to reflect against. Here's an example. I think Al Gore made it very popular a number of years back that parts of San Francisco would be underwater if global warming was to continue the way that the past trends had shown. And in this particular project, there's an architectural firm that was interested to do a design for an aqueous barrier, for basically a dam. And it's basically something that could allow water levels to rise without having them increase in the Bay Area. But it's a very complex problem. And how do you actually get water to flow back and forth without actually rising the internal sea level? There's some other aspects to this which are very interesting, which include, could this thing also generate power, and could it, how could it be funded? And could this be something that that entrepreneurs could even get involved with and effectively get return on investment for doing parts of this? And I assume that what we learn out of these types of designs, they would go into not necessarily aqueous barriers of this stage, but smaller projects around the world where these types of ideas are, where the timing is better, where they're needed now. Here's another example. I'd say that self-driving cars is a lot closer than you might think. Certainly, we've seen some examples of it. Google has a self-driving car. A lot of the safety features that are in the very high-end cars today are pretty close to self-driving. Like there's features where the car cannot hit a person. It has sensors. It would know that someone is about to step out in front of a person. Cars can park themselves. You've seen versions of that. You've seen versions of not being able to change a lane into another car. There's a lot of these examples of different features plus different technologies converging. And then, of course, there's GPS. And you just think about all these things coming together. So this project, this is really more of a control systems project. And it's about the specific control of the automated vehicle, and in this case, being able to avoid something and go back into a lane, basically guide the car. But again, it's looking at it from all perspectives. Here's one more example. I promise not to do 25 of these. It's my last one. This one is the recycling of epoxy composites. And epoxy composites are like fiberglass or carbon fiber. And the basic idea of epoxy is that you have a chemical or sometimes two chemicals, and when you join them together, they lock in such a way that they're very strong. But because of this process of creating them, undoing them to recycle it is very hard. Because you've made this composite that's strong. And so, along with this company, the project team worked on both the design of a process and the equipment that would be needed to actually undo those bonds and to recycle these materials. And they also looked at combinations of the business cases where, for example, one of the places where where this material is used is in the very large windmill shafts, the blades of windmills. And so they're discussing, they're working on both the model that people who produce these windmills would use in making their blades in such a way that they could actually take them back and recycle them. So it's a sustainable, full life cycle analysis type of project. Anyway, there's many, many projects, but they're just giving you an idea of some of the breadth of the projects. Before I kind of preview what some of the projects are that we're going to look at for this year, I wanted to basically give you just a little bit of context of how I guess businesses evolve. And my only point really on this slide is that when businesses use technology, it's kind of in two different phases. In the first phase, you think of a startup, when you're really early, it's pretty common that the business model that isn't really known. You don't have much data. You don't know necessarily what this product is precisely. There's a lot of technology risk. You're not sure who the customer is. You're not sure how they're going to pay for it. There's a lot of ambiguity in that early part. And this is, I guess, by now famous Silicon Valley terminology, but companies tend to go through pivots. So they try something, and they use that as a basis to collect data. They spend as little money as they can. The information is more important. And then they make an adaptation, and they try that next version. and then again, that's their hypothesis that would work. And if that doesn't, then they're using that to collect more data. They go through a number of pivots until they find a model that actually works. If you run out of money before you find a model that works, then of course your company will end. Software companies are famous for going through something like 9 pivots before they find a working business model. Anyway, once you find a model that works, then the whole goal of the company changes. The motivations of the company change. It's no longer searching for what is that model, but now it's refining and scaling and basically growing. And you can't grow before you really find the working model. There's a timing between searching and growing. And when you look at these projects, they're across this whole range. And what you'll find is that some of these projects are really early, and there's a lot of adaptation to be done, and the degree of how well the project is defined the degree is that it's not very defined. It's relatively open. And that's because of the stage of the technology and the stage of the idea. And then there's other projects where the model is really understood and refinement is needed and scale is needed. And there's a different purpose. And I should point out that people who are usually good in, say, one of these phases, like the finding of how it's going to work, are usually not that interested in being on projects where later on it's the narrow, detail-specific improvements. And the other way around, too. Those people who are often really interested in the later stage projects are very uncomfortable with the vagueness of the early parts of where this all came from. So this is a little bit to you in terms of when you look at these projects, you could think about how comfortable you are with the degree of how well the project is defined. And that's, of course, designed into where it fits in kind of the whole stage of things. So specifics on what happens in the capstone projects. Of course, you've got a number of deliverables here. One is what you're going to do technically, the solution itself. You've heard a number of times that you're going to make a number of presentations. These are business presentations. You're going to make a poster along the lines of those 3 examples that I just showed a minute ago. There's going to be a final presentation. That's, of course, at the end of the year. And there's something written. And that's, of course, basically your master's project thesis type of report. Everyone writes one of those individually. Even though you have a group project, that report you write on your own. It's what you contributed to it. Here's a preview of who are the companies that are participating so far. It's not a full list of companies. Clearly, these are all great brand name companies and good representatives of Silicon Valley and so forth. I should say that not every company is on here. That was some point. I basically can't leave this slide without making that point. For example, we have we are expecting a project from GE, and GE is doing some really interesting things. They've opened a new software design center in San Ramon, like 25, 30 minutes from here. And in fact, our dean is on the advisory board of this area of GE, and one of their executives is on the Funding Institute advisory board, and I've had some meetings with the chief technical architect of what's going on. And what they're working on is basically the future of machine-to-machine communications. It's some software that would, in the kind of abstract way of, like, almost to the point of ridiculousness, but just to make my point, it's the idea that what would be the interface so that you could use a mobile application to control something like a power plant? What do you need in the middle so that you could actually do things that you would never otherwise be able to control with such a simple interface? What do you need to do that safely and properly? Anyway, they're working some really interesting things, and we're expecting a project there, but it's not on this list yet because we haven't defined the project fully yet. Anyway, there's a number of very interesting projects across the, from these companies. I'm going to highlight, basically at least one from every department. No extra weight is intended on this, these projects. This is more samples, just again to get the idea. In bioengineering, there's some really interesting work going on with new ways to generate tissues for skin, tissues for blood vessels, tissues for organs, so forth, and using basically, I'm not sure if the word is, basically biochemicals that your body already produces to create these things. There's a project by Professor Sengupta on unmanned aerial vehicles. It turns out that regulation is just about to change for unmanned vehicles, and that once this regulation changes, it creates a whole new opportunity for what will happen with the commercial use of these things. Qualcomm has an interesting project. I think this could really be a fun project. What they want to do is have a testing system for the location applications on their cell phones. So I'm not sure, this could be like a remote control car that carries a cell phone and drives all over, and somehow you can use that as part of the testing system to know that where the car actually is also where the cell phone is reporting it, or this could be used indoors or wherever. I'm not saying that's the way to do it, but they're interested in how would you test the location accuracy of their platforms. IOR has some, one of the IOR projects is Fidelity Investments has offered this idea of how can you gamify, make a game towards giving people ideas how they should invest their money instead of kind of more boring brochures. Is there a way that people could kind of simulate what might happen and make it more fun? Now, I should say, I've got a couple projects in a related category here. One of the things that that I'm interested to host as one of the projects is a student-run hedge fund or investment fund. And so in this case, a number of students would set an objective, an investment objective, and use a combination of qualitative signals and quantitative techniques, and come up with their thesis of how investment could be done, and we would actually simulate that over the course of the year and compare them with each other and see what kind of returns we would get and so forth. And one of our past IOR alum actually started a fund, and we're going to have them come back and explain the types of models and things that they were employing. But basically, there's a million ways to do this, so every project can really have a different one. And I'm also looking at some projects where there are kind of technology future cases, and looking at where companies can get blindsided by what's going on in the world. So I have a certain set of projects that I will be advising myself here. In mechanical engineering, example, this is a project, Applied Materials. We've had this project 2 years in the past. This is a combination of a mechatronics and robotic design, but this robot is not, it's not a robot like you think, a robot. It's it doesn't look like a human. It's a robot that handles wafers, silicon wafers, and it's a very high precision, the movement and positioning of the laser and how you control the wafer, it has to be under a very high degree of precision. And it's basically what limits their ability to go smaller and smaller on chips, on features on chips. And what they're working on is, can they understand there's a difference between what the robot does in real life versus what you think it's going to do when you design it in the CAD system. And they're working on what are the differences between what happens in CAD and what happens in real life, and can you simulate the difference between the two. Anyway, it's a very interesting problem. There's a MSc project, MSc advised project here. So far, we have not had a lot of recycling in lithium-ion batteries, and we have an idea, a hypothesis, if you will, that there is now actually a way to do it, and this project is about making progress in that way. And on the nuclear engineering side, one of the projects is with Westinghouse, and they're working on smaller, kind of more disruptive versions, cheaper versions of nuclear reactors, and also the integration of nuclear reactors with renewables like wind power or solar. And how would you control the combination of all of these things, a control system point of view of both of all three of those power sources? Okay, so there's a full range of projects here. I think you've already got in your handouts the longer list of projects. There's, if I'm not mistaken, somewhere on the order of 30, 35 projects there. A couple things to keep in mind. It's not a complete list. There will be more projects coming along. We're using this next month to get more definition, to be able to give you more definition on some of these projects. The other thing is, if you find that some of those projects are very much interesting to you, and you wanted to actually form a group even now and approach the project as a group, say, the three of us or the five of us or four, whatever, are interested in this one project, we would, we're okay with that. I mean, I'm not going to say at the second that, yes, that group will be fine. It would be nice to know that you could actually do that project. But if you're interested as a group, that might make the team dynamics of working together over the year even more enjoyable. And so we're definitely open to that this year. Okay, so I think that's a reasonable summary of what the Capstone project is about. It's possible you've got a question or two about them, and if you don't, that's okay too. But go ahead if you have questions. Yeah.
What's the feasibility of proposing a capstone project which is not on the list?
The feasibility is good. you can do that. I think it would have to either be a entrepreneurial type of project, or it would have to be with a company, and so you'd have to you would have to help bring that industry advisor to us so that we could understand what the problem statement would be from their point of view, and then we can work with them and you to define the project properly. Oh yeah.
Have there been any capstone projects with nonprofits?
Oh yeah. So we are interested in the whole spectrum. So in a way, there's the projects that are really kind of industry oriented, as in either creating something new as a product or refining some business models, so forth. But the parallel exists in social areas, and so the same thing. We're going to have some projects even on the list. I'm not sure that they're all fully on there yet, but we're looking at projects that would be either in collaboration with the Blum Center, which is for developing economies and those types of ideas. And a lot of those times, the relationship side would be with a non-government organization, and so that is fine. And again, it can be very early stage where the model isn't understood of how to use it, or it could be later where something is starting to work but it needs to be scaled, and the project can be in that category. Okay? Yeah. Uh-huh.
As far as deciding on your group, do they all have to be in the same concentration, or?
Oh yeah. Okay. So I'll just step here because I can't really see everyone. You're raising your hand, and I'm not seeing it from the lights. a lot of the projects are multidisciplinary, or at least a significant portion of them. And so, and it varies from department to department and project to project. But kind of the wider the scope of the project, the more room there is for multidisciplinary. And some projects are almost, some projects you can tell, like this is a perfect project for both an EECS and an ME person, or this is a perfect project for IUR and another area. Like you can kind of tell those. And I think we're very open to, not only open, but a lot of the projects are designed that way to cross those boundaries. Other projects are not. So it goes project by project. Yeah.
Do we have to form a team or can we work alone?
Okay, the question is, do you have to form a team or can you work alone? You per se don't have to form a team, but all of the projects have 3 to 5 people, well, a minimum of 3 people in them. And some of the projects, are designed to be even larger projects, but what we'll do there is if there's, 12 people, suppose, on a very big project, it'll get divided into 3 sub-areas. So again, you've got a group, a smaller group. But teamwork is a big part of the learning here. And so we're not likely to have a project where one person just works by themselves over the course of the year. Okay? Yeah.
So for the 2 projects you personally proposed, what would be the size of the group?
Okay, what will the size be of the projects that I proposed? And the answer to that is that depends on you. So if we only have 3 people take that project, then it will be small. But I'm prepared to have a lot of people on those projects. So because some of these are almost competition-based learning, or like kind of like goal, like large group goal projects. So something like an investment type of project. 5 different groups can technically have 5 different approaches to how they would do something, and they can learn from each other as they present. Well, this is our thesis. Another group can say, well, we have a completely different thesis about how we would approach this. But the cross-pollination of these ideas helps everybody. So it's not one of those things where the problem is only so small and too many people won't, too many people on a very narrow problem just interfere. It's like too many cooks in the kitchen type of thing. But that type of, the types of projects that I'm proposing are not like that. They would actually scale. They would allow for multiple people. Okay?
We have time for just one last question, if there is one. Great. All right. Well, we'll be around the rest of the day to talk capstone.
All right. Yeah, thank you.